Welcome to Sleeping Researcher, a channel dedicated to gentle science narration designed to help you relax and drift peacefully into sleep. This is the 7th video made so far. It's been an interesting journey producing these videos so far. I appreciate you all for listening. It'll be great if you can give this video a like and subscribe to the channel. Tonight, we will explore a fascinating and subtle topic: the perception of time versus the nature of time. Time is something we all experience every day. It guides our routines, marks our memories, and shapes our understanding of the world. Yet, time is also a concept that remains deeply mysterious. How we perceive time passing can differ greatly from what time truly is at its most fundamental level. This contrast between perception and reality invites us to look more closely at the science behind time itself. In this narration, we will gently journey through ideas from physics and psychology, exploring how our minds measure moments, how clocks measure seconds, and what the universe might reveal about time's true nature. We will consider why time sometimes seems to fly by, and at other moments crawl ever so slowly. As you listen, allow yourself to relax and let your thoughts drift like the steady flow of time itself, calm and unhurried. Together, we will uncover the delicate balance between how time feels and how time exists, inviting a peaceful curiosity that soothes the mind. Thank you for joining Sleeping Researcher. Let us begin this tranquil exploration of time. Imagine standing beside a flowing river, watching its waters glide past steadily, unceasingly. This ceaseless movement mirrors our experience of time, which seems to flow in one continuous stream. Yet, the way we perceive this flow is far from straightforward. Our minds segment time into moments, seconds, minutes, hours, giving us a sense of progression and duration. This subjective experience, often taken for granted, contrasts profoundly with the way physics describes time. While our perception is colored by memory, anticipation, and emotion, the scientific understanding of time delves into realms that challenge these intuitive notions. As we begin this exploration, it is worth contemplating how these two perspectives, our lived experience and the objective nature of time, intersect and diverge, setting the stage for a deeper inquiry into one of the most fundamental aspects of reality. Our experience of time is intimately tied to consciousness. When we feel joy, time often appears to quicken, slipping away unnoticed. Conversely, moments of boredom or discomfort may stretch, making seconds feel interminable. This elasticity of perceived time is a hallmark of human experience and has been studied extensively in psychology and neuroscience. The brain constructs time through complex neural processes, integrating sensory inputs and memories to create a coherent temporal framework. Yet, despite this subjective malleability, physical time, as described by the laws of physics, progresses uniformly, unaffected by human sentiment or awareness. This contrast raises profound questions about the relationship between mind and universe, inviting us to explore how the fleeting, personal experience of time relates to its underlying fabric. Such reflections lead us to consider not just how we perceive time, but what time itself truly is beyond our senses. From the vantage point of physics, time is often treated as a dimension, much like the three dimensions of space. In the framework of relativity, time intertwines with space to form space-time, a four-dimensional continuum that shapes the structure of the cosmos. Unlike the flowing river of our perception, time in this context can stretch and contract depending on the observer's motion and gravitational field, as shown by Einstein's theories. This scientific perspective challenges the idea of an absolute, universal clock ticking uniformly everywhere. Instead, time emerges as a dynamic element, relative and intertwined with the fabric of reality itself. The disparity between this physical viewpoint and our experiential sense of time invites us to navigate between the internal, psychological world and the external, physical universe to gain a fuller understanding. The intriguing difference between perceived and physical time also surfaces in the realm of quantum mechanics, where some interpretations suggest that the flow of time may not be fundamental but emergent. In these theories, time might arise from more basic, timeless quantum processes, challenging our everyday intuition about past, present, and future. Such ideas ripple through the foundations of science and philosophy alike, prompting us to question whether time is an intrinsic property of the universe or a construct of human cognition. As we move forward, this interplay between perception and nature, between subjective experience and objective reality, will guide our journey into the mysteries of time, revealing layers that are as fascinating as they are elusive. Our experience of time is deeply rooted in the workings of the brain, which weaves together fleeting moments into a seamless narrative. Unlike clocks or celestial motions that mark time objectively, the human mind interprets temporal information through complex neural mechanisms. These processes allow us to perceive time as continuous and flowing, creating a coherent sense of past, present, and future. The brain integrates sensory inputs, memory, and attention to construct this temporal framework, enabling us to navigate the world with a sense of order and progression. This subjective experience is crucial as it supports functions like decision-making, learning, and anticipation. Within this cognitive tapestry, time is not merely a measurement but a lived reality, essential for our understanding of cause and effect, as well as for the formation of identity itself. Neuroscientific studies reveal that time perception is remarkably flexible, influenced by factors such as emotional state, attention, and even the complexity of events we encounter. Moments of intense focus or high emotion can stretch or compress our sense of time, creating experiences where minutes feel like hours, or hours vanish in what seems like seconds. This elasticity underscores how time perception is an active, dynamic process rather than a passive reception of external signals. Furthermore, different brain regions contribute to this nuanced sense of time, including the basal ganglia, cerebellum, and prefrontal cortex, each playing a role in encoding durations, sequencing events, and anticipating future outcomes. The interplay among these areas illustrates that our experience of time is deeply embodied, intertwined with sensory and motor systems, as well as cognition. Beyond individual moments, our brain constructs a temporal horizon that extends backward into memory and forward into imagination. This mental time travel allows us to revisit past experiences and simulate possible futures, grounding our sense of continuity and purpose. Such abilities depend on the default mode network, a set of brain structures active during introspection and daydreaming. Through this network, time becomes more than a linear sequence. It transforms into a landscape where we can explore different versions of ourselves and the world. This capacity to transcend immediate reality enriches our experience, but also complicates our relationship with time, blending objective chronology with subjective meaning. In this way, time perception shapes not just how we move through the world, but how we understand our place within it. While physics may describe time as a dimension or a parameter within equations, the human brain breathes life into this concept, imbuing it with flow, direction, and significance. Our perception stitches discrete events into narratives, forming a temporal tapestry that underlies consciousness itself. This subjective construction is essential for social interaction, as shared time frames enable coordination and communication. Moreover, culture and language further influence how we experience and express time, revealing that our temporal reality is a blend of biology and environment. Thus, the human experience of time stands at the crossroads of nature and nurture, where physical phenomena meet the mind's interpretive art. As we deepen our inquiry into the human experience of time, we begin to see how perception and objective reality intertwine to create the temporal world we inhabit. This understanding opens new pathways for exploring consciousness, memory, and even the mysteries of existence itself. In the next steps of our journey, we will examine how these insights connect with broader scientific and philosophical perspectives, revealing the intricate dance between time as we feel it and time as it may truly be. The exploration continues, inviting us to reflect on the profound relationship between mind and universe. Our perception of time is a deeply personal experience, shaped not only by external events, but by the intricate workings of our own minds. Unlike the precise ticking of a clock or the steady march of seconds on a calendar, the passage of time within us can feel fluid, elastic, and subjective. Moments of joy may seem to fly by, while periods of anticipation or uncertainty can stretch endlessly. This variability invites a profound question. Could time, as we experience it, be more a creation of consciousness than a fixed backdrop to reality? The idea that time is fundamentally a psychological construct challenges traditional notions of time as an absolute entity, existing independently of the observer. Instead, it suggests that our mental processes, memory, attention, emotion, play crucial roles in shaping how we sense the flow of time, weaving together past, present, and future into a coherent narrative that grounds our sense of self. In this light, time becomes less a universal constant and more a dynamic phenomenon, emerging from the interplay of brain activity and lived experience. Neuroscience and psychology offer compelling insights into this perspective, revealing how the brain constructs temporal experience. Various regions of the brain collaborate to encode the duration of events, sequence memories, and anticipate future outcomes, effectively generating a subjective timeline. For example, changes in attention or emotional intensity can alter our internal clocks, making time feel either compressed or expanded. This suggests that time perception is not a passive reception of external signals, but an active, interpretive process. Moreover, studies of individuals in altered states of consciousness, such as meditation or certain neurological conditions, demonstrate that our sense of time can shift dramatically, further emphasizing its malleability. These findings highlight that what we call now is a mental construct, a slice of experience pieced together by the brain to create continuity and meaning. The nature of time, therefore, becomes entwined with the nature of consciousness itself, prompting us to reconsider the boundaries between mind and reality. Philosophers have long pondered the distinction between time as experienced and time as it might exist independently of perception. Some argue that time is fundamentally relational, defined only through change and events, rather than as a separate dimension. From this viewpoint, without a conscious observer to witness change, time might lose its meaning altogether. Others propose that time exists as a dimension akin to space, extending infinitely regardless of observation, a view supported by much of modern physics. Yet, even within physics, certain theories, such as those emerging from quantum mechanics and relativity, blur the lines between objective and subjective time. These ideas invite us to consider that our psychological experience of time could be a bridge connecting the tangible universe with the ineffable qualities of human consciousness. In this way, time emerges as a profound mystery, lying at the intersection of mind, matter, and the cosmos. In the realm of physics, time is defined with precise clarity as a fundamental dimension, comparable in many ways to the three dimensions of space. It serves as a measurable parameter that orders events and allows us to quantify change. Unlike the fluid and often elastic experience of time that consciousness perceives, physics treats time as an objective backdrop against which the universe unfolds. This dimension, typically represented as the fourth in the fabric of space-time, is integral to the laws governing motion, energy, and causality. Through the equations of classical mechanics and the profound insights of Einstein's theory of relativity, time is woven into the very structure of reality, shaping how objects move and how forces interact. It is not merely a passive container, but an active participant in the cosmic dance, influencing and being influenced by the presence of matter and energy. Such a conceptualization invites us to see time as a continuous variable, measurable by clocks and consistent across frames of reference, albeit with intriguing relativistic nuances that challenge our everyday intuition. Yet this scientific understanding stands in gentle contrast to our personal experience of time, which can seem elastic, subjective, and sometimes paradoxical. Psychological time stretches and contracts, influenced by attention, memory, and emotion, creating a rich tapestry of temporal experience that physics alone cannot fully capture. While a physicist's clock marks the steady passage of seconds, minutes, and hours, an individual's perception may speed up during moments of joy, or slow down in times of anticipation or distress. This divergence highlights a fundamental duality. The external, measurable dimension of time that governs the cosmos, and the internal, phenomenological time that shapes human awareness. Both perspectives offer valuable insights, with physics providing a robust framework for understanding universal processes, and psychology revealing the intimate, subjective qualities that color our daily lives. The interplay between these conceptions becomes especially evident in the context of modern scientific theories that blur the boundaries between objective and subjective notions of time. Quantum mechanics, for example, introduces elements of indeterminacy and non-classical causality, where the very sequence of events may not be strictly defined until measured or observed. Similarly, relativity shows us that time is not absolute, but relative, varying with velocity and gravitational fields, which challenges the classical idea of a universal ticking clock. These insights suggest that time, as a fundamental aspect of reality, is far more nuanced than a simple linear progression. They open doors to the possibility that our conscious experience of time might be entwined with deeper physical processes, hinting at a profound connection between the observer and the observed. From this vantage point, time emerges as a bridge linking the measurable universe with the mysteries of consciousness. While physics grounds us in the empirical reality of time as a dimension integral to the laws of nature, the human mind paints time with colors of emotion, expectation, and memory. This duality encourages a broader understanding that neither perspective alone fully encompasses the nature of time. Instead, time may reside at a complex intersection where objective measurement and subjective experience coalesce, reflecting both the external order of the cosmos and the internal rhythms of the mind. Such reflections inspire ongoing exploration, inviting us to deepen our grasp of time, not only as a scientific concept, but as a lived phenomenon, rich with meaning and wonder. In the early foundations of classical physics, time was embraced as an absolute, unwavering constant that flowed uniformly, independent of the observer or any external influence. This conception, famously articulated by Sir Isaac Newton, portrayed time as a universal backdrop, a steady, unchanging river that carries all events from the past through the present and into the future. Within this framework, time was not merely a measure, but an entity in itself, flowing equably without relation to anything external. It provided a reliable and consistent parameter by which motion, change, and causality could be understood with clarity. This notion of absolute time helped establish a baseline for scientific inquiry, enabling the formulation of laws of motion and gravitation that depend on a shared temporal framework accessible to any observer, anywhere in the universe. Yet, beneath this elegant simplicity lay an assumption that time existed independently and continuously, unaffected by the complexities of space or the observer's perspective. This classical view offered a comforting certainty, a uniform clockwork rhythm governing the cosmos, anchoring human experience to an immutable temporal scaffold. The Newtonian concept of absolute time thus set a crucial stage for the subsequent evolution of physics, defining a clear and objective temporal metric against which natural phenomena could be measured. It allowed for a shared understanding of simultaneity and duration, essential for the predictive power that classical mechanics offered. However, this uniformity also implied a separation between the flow of time and the observer's perception. It suggested that time ticked identically everywhere, regardless of context or consciousness. As science progressed, this assumption would be gently but profoundly challenged, revealing a more intricate relationship between time, space, and the observer. Still, the classical view remains an important conceptual anchor, especially when considering how human perception often aligns with the experience of a continuous and consistent passage of time, mirroring this universal flow. Within the everyday human experience, time often feels absolute and steady, much like the Newtonian ideal. Our internal clocks, governed by biological rhythms and psychological states, tend to measure time as a continuous progression, marked by predictable cycles like day and night, heartbeat, and respiration. This subjective sense harmonizes with the classical view, reinforcing the intuition that time is a constant and reliable dimension. Yet, this harmony between perception and theory is nuanced. While Newtonian time provides a stable framework for understanding physical events, human awareness of time is inherently flexible, stretching in moments of joy or contracting in periods of anxiety. This subtle divergence between the measured external time and the felt internal time underscores the complexity of temporal experience, suggesting that our perception of time is not merely a passive reception, but an active construction shaped by consciousness and context. The classical model, therefore, offers a foundational lens but does not fully capture the lived reality of time as it unfolds within the mind. The enduring influence of Newtonian absolute time also lies in its role as a contrasting backdrop against which modern scientific theories have emerged. The advent of Einstein's theory of relativity, for example, challenged the very notion of a universal time, revealing that time is intertwined with space and relative to the observer's frame of reference. This shift invites us to reconsider the simplicity of the classical view and to embrace a more fluid, dynamic understanding of time's nature. Yet even as we explore these modern complexities, the experience of time as something that flows uniformly, providing a continuous thread through our lives, remains deeply rooted in our consciousness. This duality between the classical absolute and the relativistic flexible illuminates the rich dialogue between scientific models and human perception, each offering distinct but complementary insights into the nature of time. When Albert Einstein introduced his theory of relativity in the early 20th century, he invited us into a profoundly new way of understanding time, one that departs from the comforting constancy of Newton's absolute framework. Rather than existing as a universal, unchanging backdrop against which events unfold, time became a dimension intimately connected with the fabric of space itself. This union gave rise to the concept of space-time, a four-dimensional continuum where space and time are woven together, influencing and shaping each other. In this view, time no longer marches forward uniformly for all observers. Instead, its passage depends on the observer's relative motion and gravitational environment. Clocks moving at different speeds or situated in varying gravitational fields tick at different rates, a phenomenon known as time dilation. Such insights compel us to recognize that time is not an independent entity, but a malleable aspect of the universe, inseparable from the physical context in which it is measured. This relativistic perspective challenges the intuitive experience many of us share, a steady, uniform flow of time that seems to govern our daily lives. Our perception tends to treat seconds and minutes as fixed measures, an unvarying rhythm against which memories and moments are set. Yet Einstein's revelations show that the sense of uniformity arises from our particular frame of reference, moving relatively slowly and existing within familiar gravitational conditions. When we consider objects moving near the speed of light or near massive bodies like stars or black holes, time's passage shifts in ways that defy everyday experience. This divergence between human perception and physical reality highlights an important distinction. The psychological experience of time and the physical nature of time are not always aligned. Our minds create a continuous narrative, a flowing river of moments, while the universe operates with a more complex, intertwined structure where time bends and stretches. The implications of Einstein's theory extend beyond abstract physics. They subtly influence how we understand causality, simultaneity, and the very sequence of events. The relativity of simultaneity, for instance, reveals that two observers in different states of motion may disagree on whether events occurred at the same time. This undermines the classical idea of a universal present, suggesting instead that now is a local experience rather than a global truth. Such realizations invite us to re-examine our assumptions about temporal order and challenge the notion of a singular, objective timeline. They also remind us that our conscious experience, anchored in a personal, moving frame of reference, is only one thread within the broader tapestry of space-time. In this light, time becomes a dynamic, context-dependent phenomenon, its nature shaped by motion, gravity, and the observer's viewpoint. While Einstein's framework revolutionized physics, it also bridges into philosophical contemplations about how we relate to time. The intimate link between space and time hints at a universe more interconnected and fluid than previously imagined, where the boundaries between past, present, and future blur, depending on perspective. This perspective resonates with certain contemplative traditions that emphasize the subjective and ever-changing quality of experience. Yet it is the rigorous mathematical language of relativity that allows us to quantify and predict time's flexibility, grounding these profound insights in empirical observation. The interplay between subjective perception and objective measurement enriches our understanding, revealing time as both a lived experience and a fundamental dimension of reality. Through this lens, time is not merely a backdrop to existence, but an active participant in the cosmic dance of matter and energy. As we continue to explore the nature of time, Einstein's relativity offers a crucial foundation for deeper inquiries into the cosmos and our place within it. It challenges us to expand our awareness beyond familiar temporal rhythms and to embrace the nuanced, relative qualities that define time in the universe. This journey from Newtonian certainty to relativistic fluidity invites further reflection on how time shapes and is shaped by the fabric of space, matter, and energy. Such reflections naturally lead us toward considering how modern science continues to probe time's mysteries, including the quantum realm and the search for a unified theory that might reconcile relativity with the laws governing the very small. When we think of time, it often feels like a steady, unchanging river flowing uniformly from the past into the future. However, one of the most fascinating revelations brought forth by Einstein's theories of relativity is that time itself does not flow at a constant rate for all observers. This phenomenon, known as time dilation, tells us that time can actually slow down relative to an observer's frame of reference, particularly when objects move at speeds approaching that of light or are situated within strong gravitational fields. Imagine a spacecraft traveling at an immense velocity through the vastness of space. To an observer aboard, time seems to pass normally, yet to someone watching from Earth, the clocks on the spacecraft appear to tick more slowly. This isn't a trick of measurement or perception, but a fundamental aspect of how time operates in our universe, shaped by the interplay of velocity and gravity. Time dilation reveals that time is not an absolute entity, but a relative experience, intimately woven with the fabric of space itself. The effects of time dilation become even more pronounced near massive bodies like black holes, where gravity's pull is extraordinarily intense. According to general relativity, gravity warps space-time, and as a result, time itself passes at a noticeably slower rate closer to these massive objects compared to regions farther away. This gravitational time dilation means that if one were to hover near the event horizon of a black hole, time would pass much more slowly for them relative to someone far from its influence. This counterintuitive slowing of time challenges our everyday experience, but has been confirmed through precise experiments, such as those using atomic clocks on aeroplanes or satellites orbiting Earth. In essence, time is not a universal metronome, but adapts its rhythm depending on motion and gravity, a dynamic quantity that compels us to rethink our intuitive understanding of past, present, and future. These insights open new doors to how we perceive the universe and our place within its ever-changing continuum. The concept of time dilation also invites us to consider how perception itself is intertwined with the nature of time. Our sensory experience is grounded in biological processes that operate at a human scale and velocity, giving us the illusion of the uniform flow of time. Yet, when viewed through the lens of physics, this flow is revealed to be flexible and dependent on circumstances far beyond everyday life. The relativity of time encourages a deeper appreciation of how the universe's laws transcend ordinary experience, reminding us that our perception is but one of many possible frameworks. This subtle distinction between the perception of time and time as a physical phenomenon underscores the profound complexity underlying what we might have once considered a simple, linear progression. It is within this space of discovery that science continues to explore, seeking to unify these perspectives and expand our understanding of temporal reality. As we delve deeper into the implications of time dilation, it becomes clear that time is not merely a backdrop against which events unfold, but an active participant in the cosmic dance. The malleability of time under different conditions suggests a universe far more interconnected and dynamic than classical views allowed. This realization encourages ongoing inquiry into areas such as quantum mechanics and cosmology, where the nature of time remains one of the most profound and elusive puzzles. By embracing the counterintuitive truth that time itself can stretch and contract, science invites us to perceive the cosmos through a lens that is both humbling and inspiring, inviting a continuous re-examination of reality's most fundamental dimension. Such reflections naturally lead us to consider new frontiers where the quantum and relativistic realms might converge, deepening our quest to understand time in its fullest complexity. One of the most compelling validations of the flexible nature of time comes from experiments involving atomic clocks carried aboard airplanes. These clocks, known for their extraordinary precision, serve as delicate instruments that measure the passage of time with unparalleled accuracy. When synchronized atomic clocks are flown around the Earth on high-speed aircraft and then compared to identical clocks that remain stationary on the ground, subtle but measurable differences emerge. These discrepancies align perfectly with the predictions of Einstein's theory of relativity. Time, as measured by the moving clocks, ticks slightly slower relative to their stationary counterparts, demonstrating that the rate at which time flows is influenced by velocity. Such experiments do more than confirm mathematical equations. They provide tangible proof that time is not an immutable river, but a variable phenomenon, susceptible to the conditions of motion and gravity. These findings invite us to reconsider our everyday experience of time, reminding us that the seemingly constant progression of seconds is, in fact, a complex interplay of space, speed, and gravity. Further reinforcing this extraordinary concept, the Haffler-Keating experiment conducted in the 1970s elegantly demonstrated how time dilation manifests in practical terms. By flying atomic clocks eastward and westward around the globe, scientists observed that the clocks traveling eastward, moving in the same direction as Earth's rotation, experienced a slight loss of time compared to those moving westward or remaining on the ground. This result is a direct consequence of both special and general relativity, showing that not only velocity, but also gravitational potential affect the flow of time. The fact that such tiny increments of difference, measured in mere billionths of a second, can be detected and replicated speaks volumes about the precision of modern science and the subtlety of time's nature. These experiments gently unravel the layers of our temporal understanding, grounding abstract theoretical concepts in the realm of observable reality. Atomic clocks have since become indispensable in technologies that rely on precise time measurement, such as the Global Positioning System, which must correct for time dilation effects to maintain accuracy. The satellites orbiting Earth experience both velocity-based and gravitational time dilation, causing their onboard clocks to run at a different rate than those on the planet's surface. Engineers must factor these relativistic effects into their calculations to ensure that navigation signals remain reliable. This pragmatic necessity serves as a daily reminder that time dilation is not merely a theoretical curiosity, but an essential consideration in the intricate mechanisms of modern life. Thus, the interplay between perception and the physical nature of time extends beyond the laboratory, permeating the technology that shapes our world and our understanding of it. These experimental confirmations of time dilation challenge our intuitive grasp of time as a universal constant and highlight its dependence on the observer's frame of reference. They illuminate the subtle ways in which the fabric of space-time responds to motion and gravity, revealing a cosmos where time's flow is as variable and dynamic as the space through which it moves. By grounding these ideas in empirical evidence, science bridges the gap between abstract theory and lived experience, inviting us to embrace a view of reality that is at once more complex and more wondrous than previously imagined. As we continue to explore the boundaries of physics, these insights will guide us toward deeper questions about the essence of time itself and how it shapes the universe at every scale. As we delve deeper into the fundamental nature of time, the lens of quantum mechanics offers a perspective both fascinating and perplexing. Unlike the smooth and continuous flow of time we observe in everyday life, and even in the relativistic frameworks of classical physics, quantum theory suggests that at the tiniest scales, the realm of particles and waves, time does not behave in a straightforward manner. Here, the classical notion of a single, unchanging timeline begins to unravel, replaced by a probabilistic and sometimes non-linear tapestry. This shift challenges our conventional understanding and prompts us to reconsider what we mean by the passage of time itself. Within quantum mechanics, events do not always occur in a fixed sequence. Instead, possibilities coexist, and outcomes crystallize only upon observation. This has profound implications for the nature of time, hinting that on a microscopic level, time might be more fluid and less absolute than our macroscopic experiences suggest. One of the most intriguing aspects of quantum time is the concept of superposition, where particles exist in multiple states simultaneously until measured. This phenomenon extends to temporal states, implying that a particle's history or future may not be definitively set until an interaction occurs. Time, in this view, is not a single path, but a multitude of potentialities. Such an idea contrasts starkly with the linear progression we perceive, where cause precedes effect in an orderly march. Instead, quantum mechanics invites us to imagine a world where time's flow is intertwined with the act of observation itself, and where the very fabric of reality is woven from probabilities rather than certainties. This framework challenges the classical dichotomy between past, present, and future, suggesting a more nuanced relationship that blurs the boundaries we often take for granted. Further complicating the picture is the role of entanglement, a uniquely quantum phenomenon where particles become linked across space and, intriguingly, time. Entangled particles appear to share information instantaneously, regardless of the distance separating them, defying our everyday expectations of temporal and spatial separation. This entanglement hints at a deeper, more interconnected structure of space-time, one where the flow of time may not be the sole arbiter of causality or connection. It suggests the possibility that time itself is an emergent property, arising from more fundamental quantum processes that transcend our classical intuitions. Such insights open pathways to new theories of quantum gravity and the quest to unify the forces governing the universe. These quantum perspectives on time invite us to reflect on the profound distinction between the perception of time and its underlying nature. While our senses and consciousness experience time as a steady stream, marked by memory, anticipation, and change, the quantum world reveals a more complex and subtle reality. Time, at the smallest scales, may be discontinuous, indeterminate, and deeply linked to the observer's role, challenging the notion of an objective, universal clock. This duality between the human experience of time and its quantum behavior underscores the layered reality we inhabit, where multiple frameworks coexist and inform one another. Exploring these layers enriches our understanding and calls us to embrace both mystery and discovery in the unfolding story of time. As we stand at the crossroads between classical and quantum descriptions of time, the boundaries between perception and essence become ever more fluid. The quantum realm does not merely complicate our view, but expands it, revealing a universe where time might be a dynamic, emergent phenomenon rather than a fixed backdrop. This perspective encourages a dialogue between science and philosophy, inviting us to ponder not only the mechanics of time, but also its meaning and significance. Such reflections pave the way for further inquiry into the deep structure of reality, guiding us toward the next frontier where time's mysteries continue to unfold. At the heart of modern physics lies an intriguing paradox concerning time, the way it is perceived in everyday experience versus how it is described in fundamental theories. Classical physics, following Einstein's theory of general relativity, treats time as a flexible dimension woven into the fabric of space-time, influenced by gravity and motion. It flows smoothly, allowing clocks to measure its passage relative to observers. Yet, when we venture into the quantum realm, where particles and waves dance in probabilistic patterns, time seems to lose this familiar continuity. Quantum mechanics often treats time as an external parameter, a steady backdrop against which events unfold, rather than a dynamic entity. This disparity becomes especially pronounced when scientists attempt to merge quantum mechanics with general relativity into a unified theory of quantum gravity. In this pursuit, time refuses to behave as a single, coherent concept, revealing a profound tension between perception and the underlying nature of reality. The problem of time in quantum gravity challenges our deepest intuitions. Unlike space, which can be quantized and understood in discrete units, time appears to resist such straightforward treatment. Some approaches suggest that time might not be fundamental at all, but an emergent phenomenon arising from more basic, timeless quantum processes. In these frameworks, what we perceive as the flow of time could be a macroscopic illusion, a consequence of entanglement and information exchange within complex quantum systems. This idea unsettles the traditional view of time as a universal backdrop, inviting us to reconsider what it means for something to occur or change. It also raises philosophical questions about causality and the arrow of time, prompting a dialogue between physics and metaphysics that continues to evolve. Experimental efforts to probe the nature of time at the quantum level remain limited, as the scales involved are incredibly small and energies extraordinarily high. However, theoretical models such as loop quantum gravity and string theory offer glimpses into possible resolutions. Loop quantum gravity, for instance, envisions space-time as composed of tiny, discrete loops, potentially dissolving the smooth flow of time into a granular structure. String theory, on the other hand, introduces additional dimensions and novel symmetries that could reconcile temporal concepts across scales. Each model brings its own interpretation of time, from timeless states to multiverses, where time may stretch and fold in unexpected ways. These insights compel us to distinguish between our psychological experience of time, the steady rhythm marked by clocks and memories, and the elusive, possibly non-linear reality described by fundamental physics. Such distinctions underscore the richness and complexity of the problem of time in quantum gravity. The tension between time as a measurable quantity and time as a fundamental construct also impacts our understanding of cosmology. The origin of the universe, the nature of black holes, and the fate of space-time all hinge upon how time behaves under extreme conditions. If time emerges from more basic quantum phenomena, what does this imply about the moments before the Big Bang, or inside singularities where classical notions of time break down? These questions reveal that time is not merely a parameter to track events, but a profound aspect of reality whose true nature remains elusive. Scientists continue to explore mathematical formulations and thought experiments that might illuminate this mystery, hoping to bridge the gap between perception and essence. Each step forward deepens our appreciation for the subtle interplay between time's observed flow and its underlying fabric. As we contemplate the problem of time in quantum gravity, we recognize that it is more than a technical challenge. It is a window into the fundamental structure of existence. The interplay between time's perception and its theoretical description invites us to expand our conceptual horizons and embrace uncertainty as part of the scientific journey. By probing the boundaries where classical and quantum ideas meet, physicists strive to uncover a coherent narrative that unites the passage of time with the timeless laws governing the cosmos. This ongoing quest not only advances our understanding of the universe, but also enriches our reflections on the nature of reality itself. With each discovery, the mystery of time unfolds further, guiding us toward new questions and deeper insights. As we shift our focus from the grand cosmic scales to the intimate realm of human experience, we encounter a profound divergence. The contrast between psychological time and physical time. Physical time, as measured by clocks and defined by the laws of physics, unfolds in a steady, uniform manner. It is objective, quantifiable, and universal, at least within classical frameworks. Yet, our internal experience of time, psychological time, dances to a different rhythm. It is elastic and subjective, influenced by attention, emotion, and memory. Moments of joy may seem to expand, while periods of waiting or distress can contract or drag endlessly. This disparity between what science records and what we feel invites us to consider time not only as a physical dimension, but also as a mental phenomenon. The study of this psychological flux reveals the intricate ways our brains construct time, weaving sensory input and cognitive processes into a flowing narrative that is deeply personal and context-dependent. The distinction between psychological and physical time becomes especially apparent when we examine how different states of consciousness modulate our perception of duration. For example, during moments of intense focus or flow, hours may pass unnoticed, while boredom or anxiety can make short intervals feel interminable. Neuroscientific research suggests that these variations arise from changes in neural activity within brain regions responsible for tracking time intervals and integrating sensory information. Despite the constancy of physical time, our minds create an internal clock that is malleable and sensitive to our experiences. This interplay challenges the notion that time is a singular, immutable dimension, and instead proposes a duality where subjective experience and objective measurement coexist, each unveiling different facets of temporal reality. Understanding this duality enriches not only our grasp of human cognition, but also our appreciation of time's multifaceted nature. Philosophers and scientists alike have long pondered the implications of this divergence. If physical time is considered the true framework within which events unfold, psychological time represents the lived reality of those events. This raises intriguing questions about whether time exists independently of observers, or if it is in part shaped by consciousness itself. In the realm of physics, time often appears as a parameter embedded in mathematical equations, devoid of sensation or meaning. In contrast, psychological time is inseparable from experience, colored by personal history and emotional states. Such reflections invite a broader inquiry into how reality is constructed and perceived, suggesting that time is not merely a backdrop, but an active participant in the unfolding of existence. This perspective encourages a dialogue between empirical science and introspective awareness, bridging the gap between external measurement and internal experience. Moreover, the divergence between psychological and physical time highlights the limitations inherent in any singular approach to understanding time. While physics seeks universal laws that govern the cosmos, psychology and neuroscience reveal the variability and subjectivity of temporal perception. Both are essential, yet they operate in different domains, one objective and external, the other subjective and internal. This complementary relationship underscores the necessity of interdisciplinary exploration when addressing the enigma of time. It reminds us that to fully appreciate the nature of time, one must consider both the cold precision of a clock and the warm flow of human consciousness. In this way, the study of time becomes not only a scientific endeavor, but also a deeply human one. As we continue to unravel these threads, we open the door to new insights that transcend traditional boundaries. This unfolding understanding of psychological and physical time naturally leads us to examine how these concepts interact in the context of modern physics, where time itself becomes a malleable entity rather than a fixed backdrop. The interplay between subjective experience and objective description offers fertile ground for exploring how time might emerge from deeper, timeless principles. In considering these themes, we prepare to delve into the ways that time's elusive qualities challenge our conventional wisdom and inspire innovative theoretical frameworks. Thus, our journey continues, guided by curiosity and the quest to bridge perception with reality. The perception of time, unlike the ticking of a clock, is not governed by a single, centralized mechanism within the brain. Instead, it emerges from a complex interplay of multiple neural circuits that work in concert to create our seamless experience of temporal flow. Neuroscientific research has identified several key brain areas that contribute to this intricate process. Among them, the basal ganglia and the cerebellum play essential roles in processing intervals of time, particularly in the range of milliseconds to seconds. These structures are thought to act as internal timekeepers, allowing us to perceive durations and synchronize movements with remarkable precision. Simultaneously, the prefrontal cortex, known for its role in higher cognitive functions, integrates temporal information over longer intervals, supporting our ability to plan, anticipate, and remember sequences of events. This distributed network underscores the idea that time perception is not a singular faculty, but rather a dynamic construction shaped by the brain's constant effort to interpret sensory input in relation to past and future moments. At the cellular level, neurons within these brain regions employ mechanisms that resemble sophisticated clocks, utilizing patterns of electrical activity and chemical signaling to encode temporal information. For example, the striatum, part of the basal ganglia, receives dopaminergic inputs that modulate timing accuracy. Variations in dopamine levels have been shown to influence how individuals estimate the passage of time, which is why time may seem to slow down or speed up under certain emotional states or neurological conditions. Furthermore, the cerebellum contributes by fine-tuning motor timing and sensory predictions, ensuring smooth coordination and anticipation of events. These findings illustrate that our brain's measurement of time is not a passive recording, but an active, adaptive process. It constantly recalibrates to maintain alignment with the external world, highlighting the fluid and subjective nature of temporal experience. Such insights deepen our appreciation for the brain's remarkable capacity to weave together disparate signals into a coherent sense of continuity. Beyond these core timing circuits, the parietal cortex and insular cortex have emerged as important players in our awareness of time's passage. The parietal cortex helps integrate sensory inputs with spatial and temporal information, contributing to the perception of duration and event order. Meanwhile, the insula is thought to mediate the feeling of time's flow, linking internal bodily states with the subjective sense of now. These regions collaborate with memory systems, such as the hippocampus, to anchor temporal experiences within a contextual framework. This neural symphony allows us not only to perceive isolated moments, but also to construct narratives that span past, present, and future. It is within this complex architecture that the brain transforms raw data into the rich tapestry of temporal experience, revealing that our sense of time is a product of both neural computation and conscious awareness. Hello, recent advances in neuroimaging and electrophysiology continue to unravel how the brain encodes time, revealing oscillatory patterns and predictive coding strategies that underpin temporal perception. Neural oscillations, rhythmic fluctuations in brain activity, appear to provide a temporal scaffold, organizing information into discrete segments. These rhythms may synchronize different brain areas, coordinating the timing of perception and action. Predictive coding, on the other hand, suggests that the brain constantly generates expectations about upcoming events, using timing cues to minimize surprise and optimize responses. Such mechanisms emphasize that time perception is inherently anticipatory, shaped by the brain's drive to adapt and function efficiently within an ever-changing environment. This dynamic interplay between neural timing and prediction highlights the elegance of the brain's temporal machinery. Understanding how our brain measures time invites us to reconsider the nature of time itself, bridging subjective experience with the physical frameworks that describe reality. While physics may treat time as a dimension woven into the fabric of the universe, our neural architecture interprets it through a lens sculpted by evolution and survival needs. This duality underscores a profound truth. Time as we know it is both an external parameter and an internal creation. As we continue to explore the brain's temporal networks, we open new avenues to grasp how consciousness and reality intertwine, setting the stage for deeper inquiries into the essence of time. With this foundation, we are poised to investigate how the elusive qualities of time challenge and enrich our understanding across disciplines. Our perception of time is remarkably malleable, shaped by the intricate workings of the brain rather than by any external clock alone. In moments of intense emotion or urgent need, such as during emergencies, time often seems to stretch and slow down. This phenomenon, sometimes called temporal dilation, arises as the brain heightens its attention and processes more information per unit of subjective time. Evolutionarily, this could offer a survival advantage, allowing individuals to react more effectively when faced with danger. Conversely, in states of boredom or monotony, time can feel sluggish, dragging on endlessly as the mind receives fewer novel stimuli. These variations highlight the brain's role as an active interpreter of temporal flow rather than a passive recorder. Our experience of time is thus a dynamic interplay between external events and internal cognitive states, revealing a fascinating discrepancy between physical time and psychological time. Exploring these temporal illusions invites us to question the assumption that time is a fixed, uniform entity, and instead consider it a construct deeply intertwined with consciousness. The brain's perception of time also depends on context and expectation, further complicating the relationship between real and experienced time. For instance, when engaged in a captivating activity, hours may seem to pass in what feels like moments, while moments of waiting can feel interminable. This subjective acceleration and deceleration of time illustrates how attention and emotional engagement modulate temporal awareness. Neuroscientific research suggests that different brain regions, including the insula and prefrontal cortex, contribute to this nuanced experience by integrating sensory input, memory, and emotional valence. Meanwhile, physical time, as measured by clocks and celestial cycles, progresses steadily and independently of our inner world. This divergence raises profound questions about the nature of reality itself. Can time be fully described by objective measurements, or does its essence forever remain filtered through the human mind? The distortions we experience remind us that time is as much a psychological phenomenon as a physical one. Such reflections encourage a deeper exploration of how humans construct temporal reality and why it matters to our sense of self and existence. Intriguingly, temporal illusions extend beyond ordinary experiences and can be experimentally induced through various sensory manipulations. For example, when presented with rhythmic stimuli or altered sensory feedback, participants often report changes in perceived duration. These experimental findings reveal that our temporal faculties rely on complex neural mechanisms, integrating multisensory information to create a coherent timeline. The perception of time can be compressed or expanded, depending on the predictability and intensity of stimuli, demonstrating that time perception is not a simple counting process, but a rich, context-dependent synthesis. This malleability challenges classical views of time as a linear, immutable flow, and suggests it is a flexible dimension shaped by cognition. Such insights have implications not only for psychology and neuroscience, but also for philosophy, and physics as they blur the boundaries between objective and subjective realities. By studying these distortions, we gain a clearer picture of the mind's role in shaping temporal experience and the elusive nature of time itself. Moreover, the phenomenon of time distortion offers a window into altered states of consciousness, such as those induced by meditation, hypnosis, or psychoactive substances. In these states, individuals frequently report profound changes in time perception, ranging from timelessness to time loops and fragmentation. These subjective experiences suggest that the brain's temporal processing systems are deeply connected to the mechanisms underlying awareness and selfhood. They reveal that our sense of temporal continuity is not an absolute given, but a fragile, constructed phenomenon that can shift dramatically under certain conditions. Understanding these shifts might illuminate the neural correlates of consciousness and the ways in which temporal awareness anchors our experience of reality. Such studies bridge the gap between the physical measurement of time and its lived phenomenological quality. This exploration of time distortion thus opens avenues not only for science, but for a more profound appreciation of human experience and its temporal fabric. As we contemplate the curious ways in which our perception of time bends and stretches, it becomes clear that time is not a singular, uniform entity, but a multifaceted phenomenon. The interplay between the objective passage of time and the subjective experience thereof reveals layers of complexity that challenge simple definitions. These temporal illusions remind us that our conscious experience is deeply rooted in neural processes that interpret, anticipate, and sometimes reshape the flow of moments. This understanding invites us to look beyond conventional frameworks and consider the rich tapestry of time as it is lived and felt. In doing so, we prepare to engage with broader questions about how time influences cognition, memory, and identity, setting the stage for further exploration into the relationship between temporal perception and the nature of reality. Let us now turn our attention to these broader implications and the scientific inquiries they inspire. The perception of time is not only a psychological construct, but also a cultural one, shaped and colored by the norms, values, and rhythms unique to diverse societies. Scientific inquiries into how different cultures perceive and organize time reveal striking contrasts that invite us to reconsider the universality of temporal experience. For example, some cultures view time as a linear progression, moving steadily from past to future, emphasizing schedules and punctuality as markers of respect and efficiency. In these contexts, time is often segmented into clearly defined units, enabling precise planning and coordination. However, other cultures embrace a more fluid, cyclical conception of time, where events recur in natural rhythms and the past, present, and future are interconnected in a continuous flow. This cyclicality often encourages a more flexible approach to deadlines and a deeper attunement to environmental and social cues. Such cultural variations underscore that time, though measurable by clocks and calendars, is profoundly interpreted through the lens of collective meaning and lived experience. These perspectives enrich our understanding of temporal perception, showing it to be as much a social phenomenon as a neurobiological one. Further exploration into cultural time perception reveals how these differing temporal frameworks influence not only daily behavior, but also deeper cognitive processes such as memory, attention, and decision-making. In cultures with a linear time orientation, for instance, individuals may prioritize future-oriented planning, setting goals with a clear endpoint and valuing progress as a measure of success. Conversely, cultures with a more holistic or event-based sense of time often emphasize present moment awareness and relational harmony, where the timing of actions is responsive rather than rigid. This can affect how time is experienced subjectively. Moments may feel elongated or compressed, depending on cultural context and the situational demands placed upon individuals. Scientific studies using cross-cultural psychology and anthropology have shown that these differences extend to physiological responses and brain activity related to temporal processing, suggesting that our environment and cultural upbringing shape neural mechanisms as well. This interplay between culture and cognition invites a more nuanced appreciation of time as simultaneously an external dimension and an internal experience, mediated by the social fabric in which we live. The impact of cultural perspectives on time also emerges in how societies assign value and meaning to it. In some cultures, time is closely tied to productivity and economic output, encouraging a future-focused mindset that can foster innovation and growth, but may also engender stress and a sense of urgency. In contrast, other cultures may prioritize leisurely pacing or cyclical rituals that celebrate the present, fostering social cohesion and well-being through shared temporal practices. These differing valuations shape not only individual lifestyles, but also communal structures, influencing everything from work patterns to ceremonial life. The scientific study of these cultural differences in time perception thus adds depth to our understanding of human experience, reminding us that time is not merely a physical constant, but also a canvas upon which societies paint their unique relationships with existence and change. By appreciating this cultural dimension, we become more aware of the ways in which our own temporal orientation is both a product of and a contributor to the broader human story. Moreover, the recognition that time perception varies across cultures opens intriguing pathways for interdisciplinary research, bridging neuroscience, anthropology, and philosophy. By examining how culturally shaped temporal frameworks interact with universal biological rhythms, scientists can better understand the plasticity of human experience and the adaptability of the brain in interpreting the passage of time. This knowledge has practical implications as well, informing cross-cultural communication, education, and healthcare, where differing temporal expectations can lead to misunderstandings or conflicts. On a deeper level, this line of inquiry encourages us to question the nature of time itself, whether it exists independently as a fixed reality or emerges through the dynamic interplay between mind, culture, and environment. Such questions propel us beyond the confines of clock time and invite reflection on the profound ways in which time is woven into the fabric of human life. As we continue to explore the mysteries of time perception, we begin to glimpse the intricate dance between the universal and the particular in shaping our experience of reality. Memory serves as a cornerstone in our perception of time, shaping how we experience the past and estimate the duration of events. Unlike the steady ticking of a clock, our sense of time is fluid, deeply intertwined with the way memories are constructed and recalled. When we remember a past event, we do not retrieve a perfect recording, but rather a reconstructed narrative, pieced together from fragments that the brain actively organizes. This process can elongate or compress our sense of how long an experience lasted, depending on the richness of details and emotional significance attached to those memories. For instance, moments filled with intense feelings or novel experiences often feel longer in retrospect as the brain encodes more information, creating a denser tapestry of recollections. Conversely, routine or uneventful stretches of time may appear to pass quickly because fewer unique memories are formed to mark their passage. Thus, memory does not merely archive the past, but actively influences our ongoing experience of time's flow. This dynamic relationship reveals the inherent plasticity of temporal perception, demonstrating that our experience of time is not fixed, but continually shaped by the mind's interpretive mechanisms. The neurobiological underpinnings of this phenomenon highlight the role of specific brain regions, such as the hippocampus and prefrontal cortex, in encoding and retrieving temporal information. These areas collaborate to create a coherent sense of when events occurred, situating them within a personal timeline that is essential for learning and decision-making. Interestingly, disruptions in memory systems, whether due to injury or neurodegenerative disease, can profoundly alter one's sense of time, leading to moments that feel disjointed or timeless. This suggests that time perception is not simply a passive process, but an active construction, reliant on the integrity of memory networks. Moreover, research into the brain's default mode network reveals that spontaneous mental activity during rest involves simulating past experiences and anticipating future ones, intertwining memory and prospective thought in a continuous temporal loop. This ongoing mental simulation reinforces the fluidity of time perception as the boundaries between past, present, and future become permeable in the mind's eye. Such insights invite us to reconsider time, not as a rigid succession of moments, but as a subjective experience constantly sculpted by cognitive processes. Beyond individual cognition, the construction of memory also shapes collective and cultural understandings of time. Societies develop shared narratives and historical accounts that influence how groups perceive their past, present, and future trajectories. These collective memories serve as anchors for identity and continuity, yet they are also subject to reinterpretation and forgetting, reflecting the malleable nature of temporal frameworks at a communal level. The way memories are emphasized or suppressed within a culture can alter the collective sense of historical duration and significance, contributing to diverse temporal rhythms across societies. This interplay between memory and time perception underscores the idea that time is not merely an external dimension, but is deeply embedded in the social and psychological fabric of human existence. As we examine these layers of temporal experience, we begin to appreciate the profound ways in which memory acts as a bridge, connecting the fleeting present with an ever-evolving past. The fluidity of time perception, as influenced by memory, also manifests in the subjective feeling of duration during lived experiences. When attention is focused intensely, such as during moments of danger or deep concentration, the brain's temporal processing can shift, causing time to dilate or contract in awareness. This malleability highlights that our sense of time is intimately tied to cognitive states and emotional context. The construction of memory plays a crucial role here, as these altered temporal experiences are encoded distinctively, often standing out vividly in the mind's archive. Over time, the accumulation of such memories contributes to an individual's unique temporal landscape, where the passage of time is not uniform, but textured by personal meaning and psychological rhythms. This perspective challenges the notion of objective time as a constant flow, inviting us instead to view it as a dynamic experience shaped by the interplay of memory, attention, and consciousness. Through this lens, time reveals itself as a living construct, continuously formed and reformed within the mind's unfolding narrative. As science continues to unravel the connections between memory and time perception, we are drawn closer to understanding time not only as a physical dimension, but as a deeply subjective phenomenon. The recognition that our sense of past and duration is shaped by memory construction opens new avenues for exploring how the brain integrates temporal information with emotion, cognition, and culture. This ongoing inquiry bridges disciplines and perspectives, encouraging a holistic approach to the mysteries of time. By appreciating the fluidity and complexity of temporal experience, we move beyond simplistic measures of time and embrace a richer, more nuanced view of how we live within its flow. This evolving understanding sets the stage for further exploration into how the mind navigates the delicate balance between the constancy of physical time and the mutable nature of psychological time. In our daily lives, time appears to flow in a single direction, from past to future, an experience so fundamental that it often goes unquestioned. This intuitive sense of time's directionality is what physicists refer to as the arrow of time. At its core, the arrow of time is a manifestation of the second law of thermodynamics, which states that in an isolated system, entropy, a measure of disorder or randomness, tends to increase over time. This principle establishes a clear asymmetry in the behavior of natural processes. While microscopic physical laws may be time-symmetric, the macroscopic world we inhabit unfolds irreversibly, with order gradually giving way to disorder. Consider a broken glass. It shatters and scatters, but the scattered pieces do not spontaneously reassemble themselves. This irreversible progression from less probable, ordered states to more probable, disordered states underpins our experience of time moving forward, rather than backward. The arrow of time thus links a fundamental physical property, entropy, to the way we perceive temporal passage, anchoring subjective experience to objective phenomena. Delving deeper, the arrow of time challenges us to reconcile the unyielding flow of time with the nature of physical laws. At the microscopic level, the equations governing particles and forces are largely time reversible, meaning they do not intrinsically favor a direction. Yet, when countless particles interact, patterns emerge that align with the thermodynamic arrow. This emergence of time's directionality from underlying symmetry is a profound insight in modern physics. It suggests that our perception of time's unidirectional flow arises not from fundamental laws themselves, but from the statistical behavior of complex systems. This perspective invites reflection on how the brain processes temporal information. Our memories, thoughts, and anticipations unfold against this backdrop of increasing entropy, grounding subjective time in the physical realities of the universe. Consequently, the arrow of time is not merely a scientific abstraction, but a bridge connecting the tangible world with the intangible flow of human experience. It is within this interplay that the nature of time reveals its layered, intricate character. Moreover, the arrow of time influences not only our perception, but also the very structure of causality, the relationship between cause and effect. Because entropy increases, causes precede effects, and this ordering establishes the temporal framework within which events unfold. This causal sequence is reflected in how we remember the past but not the future, how we anticipate what is to come yet cannot alter what is already transpired. The thermodynamic arrow thus shapes the narrative we construct about our lives and the universe. It informs how we understand change, growth, decay, and ultimately the passage of existence itself. The intimate connection between entropy and time's direction suggests that time is not a mere backdrop against which events occur, but an active participant in the unfolding of reality. As we explore these dimensions, we begin to see time as a phenomenon deeply intertwined with physical laws, consciousness, and the fabric of experience. To understand why time seems to flow in a single direction, we must turn to the concept of entropy, a measure of disorder or randomness within a system. In the natural world, isolated systems tend to evolve towards states of higher entropy, a principle enshrined in the second law of thermodynamics. This inexorable increase in disorder provides a physical basis for the arrow of time, revealing why moments pass from past to future and never in reverse. Our everyday experience, marked by irreversible processes such as the melting of ice or the fading of a sunset, echoes this fundamental tendency. Each event nudges the universe toward greater entropy, embedding time's forward progression into the very fabric of physical reality. As we observe the cosmos, from the smallest particles to the grandest galaxies, the relentless march toward equilibrium becomes apparent, giving time its unmistakable directionality. This linkage between entropy and time's flow also clarifies why we perceive time as a steady progression, even low at the microscopic level. Physical laws often display symmetry with respect to time. The intricate dance of atoms and molecules is governed by equations that do not inherently distinguish past from future. Yet, when these microscopic interactions aggregate, they produce macroscopic phenomena where entropy tends to increase, breaking the symmetry and instituting a preferred temporal direction. Our consciousness, embedded in this physical framework, experiences time as a continuum moving forward, shaped by the irreversible transformations that define our reality. In this way, the physics of entropy bridges the microscopic and macroscopic worlds, connecting fundamental particles to the unfolding narrative of existence. The flow of time, then, is not merely a subjective impression, but a manifestation of physical principles that govern change and complexity. Interestingly, the perception of time's passage is deeply influenced by the interplay between entropy and memory. Our minds store information about past events, creating a temporal archive that is inherently asymmetric. Memories are formed and retained, while the future remains unknown and unrecorded. This asymmetry mirrors the thermodynamic arrow and reinforces our experience of time's unidirectional flow. As entropy increases, the accumulation of records and effects of prior causes become tangible markers of history, anchoring our awareness firmly in the present moment. The act of remembering thus aligns with the physical reality of growing disorder, weaving together the subjective sensation of time with the objective expansion of entropy. Through this lens, time's flow is not only a cosmic phenomenon, but also a cognitive one, intimately connected to the structure of knowledge and experience. Beyond the everyday, the relationship between entropy and time challenges our understanding of the universe's origin and ultimate fate. At the moment of the Big Bang, the universe is thought to have been in a state of extremely low entropy, a highly ordered beginning from which entropy has since increased. This initial condition set the stage for the temporal arrow we observe, with time flowing outward from a point of minimal disorder toward ever greater complexity and randomness. The expansion of the cosmos itself is entwined with this thermodynamic journey, linking the nature of time to the evolution of the universe on the grandest scale. As entropy continues to rise, the future unfolds in ways that remain mysterious yet inevitably shaped by these fundamental physical laws. In contemplating time's origin, we glimpse the profound connection between the cosmos's history and the flow we so intimately experience. While entropy provides a compelling explanation for time's direction, questions remain about the deeper nature of time itself. Is time a fundamental entity, existing independently of matter and energy, or is it an emergent property, arising from the interactions and increasing disorder within the universe? The interplay between physical laws and perception invites us to consider time not as a static backdrop, but as a dynamic phenomenon, woven into the processes that define reality. Our awareness of time's passage, shaped by entropy, consciousness, and causality, opens a window into the subtle relationship between mind and matter. As we continue to explore these ideas, we prepare to delve further into how perception and the nature of time intertwine, revealing new perspectives on this timeless mystery. This journey brings us closer to understanding how time, both experienced and physical, shapes our existence. We often speak of time as something that flows, a river carrying us from the past, through the present, and into the future. This intuitive image feels natural because our consciousness experiences moments in sequence, one after another, like beads on a string. Yet, when physicists examine time closely, they find that this flowing quality is not so straightforward. In the fundamental laws of physics, time often appears as a dimension much like space, without an inherent direction or movement. Equations describing particles and forces are typically time-symmetric, meaning they work just as well if time were reversed. This raises a profound question. If the underlying rules of the universe do not demand time to flow, why do we feel it so clearly? The sensation of time's passage may emerge not from time itself, but from how our minds process change and memory. Our brains create a narrative that links events, giving rise to the impression of a continuous flow. Such reflections challenge us to reconsider whether time really flows at all, or if that flow is a feature of our perception rather than the fabric of reality. The contrast between our subjective experience and the physical description of time invites a deeper exploration of perception's role. Our senses and cognitive functions are finely attuned to detecting change and sequencing events. This biological and psychological framework constructs a temporal order that feels unmistakably real. However, this order may not be a property of time itself, but rather a byproduct of how living beings interpret stimuli and organize memories. In this sense, time's flow could be seen as a mental construct, a helpful illusion that allows us to navigate the complexities of life. Meanwhile, physical time, as described by relativity and quantum mechanics, often behaves in ways that defy everyday intuition. For instance, time can dilate or contract depending on speed and gravity, and quantum phenomena hint at a timeless underlying reality. These scientific insights highlight a divergence between the time of human experience and the time embedded in the universe's architecture. Understanding this divergence opens a path toward appreciating time not as a simple river, but as a layered phenomenon shaped by both physical laws and conscious awareness. Philosophers and physicists alike have grappled with the idea that time may be fundamentally different from our common assumptions. Some propose that the flow of time is an emergent phenomenon, arising from more basic, timeless elements. In such views, what we call the present moment is not a moving point, but a perspective within a static space-time landscape, often described as the block universe. In this model, all moments, past, present, and future, coexist, and the feeling of flow is a subjective experience embedded within this four-dimensional structure. This challenges the very notion of becoming and change as fundamental aspects of reality. Instead, change becomes a relationship between slices of this space-time, and flow becomes a narrative constructed by consciousness. Conversely, other interpretations suggest that time's flow is real and fundamental, tied to the continuous creation of reality itself. These differing viewpoints reveal the complexity of reconciling our intuitive sense of time with the abstract but precise language of physics. This ongoing dialogue between intuition, philosophy, and science encourages us to keep an open mind about what time truly is. Our experience of time's passage is deeply intertwined with memory and anticipation, connecting what was, what is, and what might be. This temporal awareness shapes how we perceive change and causality, giving meaning to events and their relationships. Yet the brain's construction of time is not infallible. Illusions and distortions demonstrate its malleability. Moments can seem to stretch or compress, depending on attention and emotion, suggesting that time as we feel it is flexible and subjective. Meanwhile, the physical universe follows a different script, one where time's progression is governed by fundamental constants and forces, indifferent to human experience. The challenge lies in bridging these two views, the objective time of physics and the subjective time of consciousness. Progress in neuroscience, quantum theory, and cosmology continues to illuminate this boundary, hinting at a more integrated understanding that honors both perspectives. As we contemplate whether time truly flows, or if flow is an artifact of perception, we open ourselves to a richer appreciation of time's multifaceted nature. Exploring the question of time's flow leads naturally into examining how our minds shape the temporal dimension of experience. If flow is a perceptual phenomenon, then what mechanisms in the brain give rise to this sensation? Researchers investigate processes such as the encoding of sequential events, the functioning of the hippocampus in memory formation, and the role of consciousness in creating a coherent temporal narrative. These studies suggest that time's flow may emerge from complex neural dynamics, stitching together discrete moments into a continuous stream. This perspective invites us to think of time less as an external, flowing entity, and more as an internal construction, a lens through which we interpret reality. Such an approach does not diminish the reality of time, but enriches it by acknowledging the active role of the observer. With this understanding, we prepare to explore further how perception and physical time interact, guiding us toward new insights about the nature of existence itself. The block universe theory offers a profound and radical perspective on time, suggesting that past, present, and future are not separate or sequential, but rather coexist within a single, unchanging four-dimensional structure. In this view, often associated with the implications of Einstein's theory of relativity, time is treated much like space, as a dimension that is equally real and fixed. Our usual experience of time flowing from one moment to the next is reconceived as a form of subjective perception, a way our consciousness moves through this timeless block. This challenges the intuitive notion that the present moment is uniquely real and that the future is open or yet to be determined. Instead, all events, whether they occurred long ago, are happening now, or will happen in the future, are equally existent within this grand temporal landscape. Such a framework invites us to reconsider the essence of change and causality, as well as the meaning of free will, within a universe where time's passage is not a fundamental feature, but an emergent aspect of our perception. Embracing the block universe theory requires us to gently let go of the deeply ingrained belief that time flows like a river, carrying us ever forward. Instead, it portrays a cosmos where all moments are laid out, much like the pages of a book that exist simultaneously, though we read them sequentially. Our conscious experience of moving through time could be likened to the act of turning pages, creating an illusion of progression where none fundamentally exists. This perspective aligns with certain interpretations of physics, particularly those that emphasize the symmetry and invariance of physical laws across time. It implies that the distinctions we draw between past, present, and future are not rooted in the fabric of reality itself, but arise from our unique vantage point within this four-dimensional manifold. Such a radical shift in understanding invites a deeper inquiry into how the brain constructs the experience of now, and how this construction shapes our sense of identity and continuity. The implications of the block universe extend beyond physics and metaphysics, touching upon our most personal experiences. If the future already exists, and the past remains as real as the present, then concepts like memory, anticipation, and decision-making acquire new dimensions of meaning. Our memories become not just records of what once was, but are aspects of a fixed temporal structure, while our hopes and plans for the future are already contained within this vast temporal tapestry. This perspective can evoke a sense of calm acceptance, as the uncertainty traditionally associated with the future dissolves into a broader understanding of existence. Yet, it also prompts profound questions about the nature of agency and how we relate to the unfolding of events. Exploring these questions helps bridge the gap between the external structure of time and the internal experience of living through it, revealing a delicate dance between physics and perception. While the block universe theory provides a compelling framework for rethinking time, it remains one of several interpretations, each with its own subtle nuances. It invites us to reflect upon the role of consciousness in shaping reality, suggesting that time's flow might be a feature not of the universe itself, but of our minds, navigating a static terrain. This perspective resonates with earlier discussions on how neural processes construct temporal experience, emphasizing that our perception of time's passage is an active, creative process. As we continue to explore the interplay between perception and the physical world, the block universe stands as a reminder of the profound mysteries still surrounding time, mysteries that challenge our intuition and open the door to new realms of understanding. In the next exploration, we will delve deeper into how these ideas influence our grasp of causality and the unfolding of events across time. As we consider the nature of time, two philosophical positions invite us to reflect deeply on the reality of the present moment: presentism and eternalism. Presentism holds that only the present is real. Past moments have vanished and future moments have yet to exist. According to this view, the flow of time is fundamental, and the present instant is a unique, ever-changing boundary between what was and what will be. This resonates closely with our everyday experience, where the now feels vivid and immediate, while the past and future seem remote or intangible. Presentism emphasizes a dynamic universe, one where reality is constantly evolving and the passage of time is an objective feature of existence. Yet, this perspective raises questions about how to account for the status of past events. Are they simply gone, or do their effects persist in some form? And what about the future? Does it hold any ontological weight before it arrives? These inquiries lead us to examine the contrast with eternalism, which offers a different, more expansive view. Eternalism presents a strikingly different picture, suggesting that all points in time, past, present, and future, are equally real. In this view, time resembles a landscape or a block, where every event exists timelessly within a four-dimensional space-time manifold. Rather than time flowing or moments coming into being, eternalism posits that all events coexist, and the sensation of moving through time arises from our conscious perspective, traveling along this fixed dimension. This conception aligns closely with the block universe theory, which we previously explored, and challenges our intuitive sense of a unique, privileged present. If every moment is equally real, then the present is not a special ontological entity, but simply a subjective label marking our current viewpoint. This challenges many aspects of how we understand causality and free will, as future events are as definite as the past. The implications of eternalism ripple through physics and philosophy alike, inviting us to reconsider the fabric of reality itself. The tension between presentism and eternalism highlights the subtle interplay between perception and ontology. The difference between how time seems to us and what time might actually be. Our neural architecture, shaped by evolution, predisposes us to experience a flowing present, rich with immediacy and change. However, the underlying physical laws, especially those of relativity, appear to favor a timeless, four-dimensional space-time where distinctions between past, present, and future blur. This contrast suggests that our perception of time's passage may be a construct of consciousness, a way to navigate a universe whose fundamental nature defies our everyday intuitions. The debate also touches on the nature of memory and anticipation. If only the present is real, how do memories retain validity? And how can we anticipate what does not yet exist? Conversely, if all times exist simultaneously, how do we reconcile this with the felt experience of becoming? These questions remind us that time remains one of the deepest and most elusive mysteries in both science and philosophy. Exploring presentism and eternalism also enriches our understanding of causality, the relationship between cause and effect that governs the unfolding of events. Presentism aligns with a causal narrative flowing unidirectionally from past to future, reinforcing the idea that the present moment is where causes translate into effects. Eternalism, with its block-like conception of space-time, challenges this linearity by embedding all events in a fixed structure, suggesting that causal relations might be understood as patterns within the whole four-dimensional tapestry. This reimagining of causality invites us to consider whether the future is predetermined or open, and how agency fits within a framework where all moments coexist. It also encourages new interpretations of time in physics, potentially reconciling quantum phenomena with relativistic space-time. By contemplating these contrasting stances, we deepen the philosophical and scientific debate surrounding the essence of time and our place within it. As we move forward, the dialogue between presentism and eternalism sets the stage for further reflection on how time shapes our understanding of reality. These perspectives, while divergent, each illuminate different facets of temporal experience and challenge us to question the assumptions underlying our sense of now. They invite us to explore how the brain constructs temporal flow, how physics describes time's structure, and how these domains intersect to form a coherent picture. The exploration ahead will take us deeper into the implications of these ideas, especially concerning causality and the unfolding of events, expanding our grasp of how time weaves through existence